Hello, welcome back to Chapter 6, Section 3, Dividing Polynomials. So what have we done so far? Let's have a moment to review. In the first video, the first example, we used long division. And they looked like that. In the second video, we introduced a shortcut, and I use that word carefully, called synthetic division, and it looks like that. And then in the third example, we use the area model. All three methods can be used for dividing polynomials, except for something. And I'm going to get to that except for something in just a moment. For this video, we're going to do this application. And don't be confused or upset by people see, oh, story problem, you'll be fine. A Van de Graaff generator. You don't need to know what that is. You will one day, okay? Google it if you don't know what it is. The information it tells you is that it produces high voltages by using small levels of current, right? So, and I'm having a hard time not getting into this, so I'm going to dip my toe in it. But we have Ohm's law, voltage equals current times resistance. So there's a relationship between the current and the voltage, okay? I probably said more than I need to. Now, one of these machines has a current that can be modeled by, and this is a function, I, that's a letter, not a number, it's not a number one, I of t, and this t represents time in seconds, t plus 2. And the power of the system can be modeled by P of t is this polynomial. Write an expression that represents the voltage of this system. So again, we get into Ohm's law and its variations of it. Don't panic about that. It'd be great if you picked up all these things on the extra side, but I can't expect that. So really all we're going to do is we're going to take this polynomial and we're just going to divide it by that polynomial. That's all it is. So it all breaks down into this. 0.5 t to the third power plus 6t to the second power plus 10t plus 0, because I need to fill in all the missing spaces, divided by t plus 2. That's all this problem is breaking down to. But now let's go back to what I mentioned previously. We have long division, we have synthetic division, and we have the area model. Out of those three, most students love synthetic division. As long as you set it up correctly, it's like boom, 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 there you got the answer. And then they get mad at me because I tell them something that I didn't mention in the previous video. I was saving it for now. Synthetic division doesn't always work. And I'm going to go back to this problem right here. This is from the first example with long division. This problem right here, I can't do with synthetic division. Why? Because of the 3. Synthetic division only works when you have x subtract h. I think the example said x subtract a, but it only works when you have x here. And then you use this part. Since this has a 3, I can't use synthetic division in this one. It messes everything up. Give it a try. If you don't believe me, go ahead and take this problem right now, pause the video, and try to do it with synthetic division. It's not going to work. So can I use synthetic division? And by the way, sorry, long division and the area model always work. Those are okay. So which method am I going to use here? Well, I need to figure out what I'm dividing by. And whether it's an x or a t does not matter. But what am I multiplying the t by? Looks like I'm just multiplying it by 1. The coefficient is 1. So this one looks like I am going to use synthetic division. Yay! Since the problem does not tell you how to do it though, you can use long division. You can use the area model. It's all good. Synthetic division, though, only works if you have no coefficient other than the hidden 1. So I'm going to use synthetic division. So I've got my 0.5, I have my 6, my 10, and don't forget the 0. I have to have all of the missing parts. I know it wasn't there, I had to put it in here. What is my h? This is t plus 2, so it's t subtract negative 2. So I'm going to put a negative 2 right here. Now here's why synthetic division is slick. I'm going to add 0, 0.5. Negative 2 times 0.5 is negative 1. 6 plus negative 1 is positive 5. Negative 2 times 5 is negative 10. 10 plus negative 10 is 0. Now, you're probably going to be tempted and say, that means there's no remainder. That's not the remainder, guys. Hate to break it to you. I got to keep going. Negative 2 times 0 is 0, and that 0 is the remainder. What? Because t to the third power, and even though I've got the 0.5, I'm just looking at the variables. This is what I'm thinking, okay? 0.5 t to the third power divided by t, just that part. I know there's all the other part to it, but I'm just looking at this part. That's going to give me 0.5 t to the second power. So this is t to the second power. And if I follow everything in order, this is t to the first power, just t. And this that right there, that tells me how many, what the constant is, which happens to be 0. There's nothing wrong with 0, okay? So I get 0.5 t squared plus 5t. But if I didn't keep track of my spacing, there's a chance that maybe I would have said, and I'm going to write not here, 0.5 t plus 5. So if I thought that was my remainder with the remainder of 0, I would have put it that times t, and that would have been my constant. So I have to make sure I keep my spaces, keep my place value, so I know what I'm going to get. And one way to double check that again is you can always remultiply. And I'll put it over here, if I multiply t plus 2 times 0.5 t squared plus 5t, and look at this, I'm actually using my area model. I'm going to get 0.5 t cubed, which is that. I'm going to get 5t plus 1t, which is 6t. I'm going to get 2 times 5, which is 10t. So I'll let you fill that in. So please, that's the thing. Synthetic division is easy, but because we hide the variables, we have to remember how to put them back in correctly. All right, we'll see you in the next video.